Hello students, hope you are all well, safe and healthy at home. Since you have finished with your UT exam, so let us start with your next syllabus, that is chapter number 7, sound. Student, this is video number 11, part 1. Now the question is, what is sound is? What is sound? What is sound? So as we know that sound is a form of energy. Sound is a form of energy which causes in us the sensation of hearing. This is what sound is. Once again, sound is a form of energy which causes in us the sensation of hearing. This is one point. Now the second point is sound is produced. Sound is produced through the vibration. Sound is produced through the vibration. Or in other words, you can say that sound is produced by the vibrating objects. So, sound reaches to us through the vibration of the medium particles. Therefore, sound requires a material medium to travel. Therefore, sound requires a material medium for its propagation. It means that sound cannot travel through vacuum. Once again, sound requires a material medium for its propagation. It means that sound cannot travel through the vacuum. Now, the fifth point, range of hearing. First, the audible range. That is from 20 Hertz to 20 kilohertz. 20 kilohertz, or you can even write it 20,000 Hertz. This is the audible range. The audible range is 20 Hertz to 20 kilohertz. Now the next is sound of frequency above 20,000, that is known as ultrasonic. ultrasonic. ultrasonic range, that is above 20 kilohertz. The sound which has a frequency more than 20 kilohertz, that is in the range of ultrasonic. Now the next is infrasonic. Infrasonic range. It is below 20 hertz. So below 20 hertz means this sound is not audible to us. You can take an example of a simple pendulum, the vibration of the simple pendulum. The pendulum vibrates, but the sound is not audible to us. So that type of sound is come in the range of infrasonic. So the next point. Since sound waves travel in a medium, the maximum displacement of the particle of medium on either side of its mean position, that is known as its amplitude. What is amplitude? The maximum displacement. The maximum displacement of the particle of the medium on either side, of its mean position, that is known as amplitude, and it is represented with letter A. Once again, students, what is amplitude? The maximum displacement of the particle of the medium on either side of its mean position is called its amplitude. Now the next is time period. The next is time period. The time taken by the particle of medium, to complete its one vibration. Is known as time period, and time period of the wave, and it is represented with letter T. Once again, students, time period, the time taken by the particle of the medium to complete its one vibration, that is known as time period of the wave. Now the third point is, that is frequency. Frequency, the number of vibration made by the medium particle. In one seconds, that is known as frequency. The number of vibration made by the medium particle in 1 second, that is known as frequency, and it is represented with letter F. Now the next D point, that is the wavelength. That is the wavelength. The distance traveled by a wave, the distance traveled by a wave in one time period is called wavelength. And it is represented with letter lambda. Clear? Then E point of this, wave velocity. What is wave velocity? The distance traveled by the wave in 1 second. The distance traveled by the wave in 1 second is known as wave velocity, and it is represented with letter V. So once again you can see frequency, the number of vibration made by a medium particle in 1 second, it is represented with F. Then wavelength, the distance traveled by the wave in one time period is called wavelength, and it is represented with letter lambda. Then wave velocity, the distance traveled by the wave in 1 second, that is known as wave velocity, and it is represented with letter V. Now the next topic is relation. Relation between wavelength, wave velocity and frequency. Now this is equal to V is equal to F lambda, and here F is equal to 1 upon T, time periods. Now this relation will help you to solve the numerical problem. You can solve the numerical problem with the help of this relation. Now the next topic is the frequency of a wave depend on the vibrating source producing the sound, while the velocity of wave and its wavelength depends on the properties of the medium in which the wave travels. This is one of the important point. Frequency, that is depend on the vibrating source, while velocity and its wavelength depends on the properties of the medium in which the wave travel. Now when the medium particles vibrate, there is a change of kinetic energy into potential energy. So sound waves are also called the elastic or mechanical waves. Now the mechanical waves are of two types. mechanical or elastic. Mechanical or elastic waves are of two kinds. Are of two kinds. One is longitudinal waves. Longitudinal wave. Another is transversal waves. Now what is the difference between these two waves, longitudinal waves and transversal waves? So let us try to understand what is longitudinal and transversal waves. Now, if the vibration of a medium particles are along the direction of propagation of the wave, so that is known as longitudinal waves. Now, longitudinal waves are like this. Like this. Now, where the density of the medium particle is higher, that part is known as compression, and it is represented with letter C. And where the density of the medium particle is less, that is known as rarefaction. Again compression, rarefaction, then again compression. So we can say that when the sound waves travels along the direction of propagation of the wave, it forms compression and rarefaction in the medium. So the distance between two compression and one rarefaction is known as its wavelength. Vice versa, the distance between two rarefaction and compression, that is known as its wavelength. Now, longitudinal waves that can travel in solid, liquid as well as gases. Can travels through solid, liquid and gases. Now the next is transversal wave. Now what is transversal waves? If the medium particles vibrate normal to the direction of the propagation of the waves, forming crest and trough, the wave is called transversal waves. It is just like this. Like this. This is the main position. Okay, this is taken as positive, this is taken as negative. Now it travels like this. Normal, I said normal. So let it is 0. Here it is 90. Then it is 180 degree. Then it is 270 degree and 360 degree. Now, so just see that the sound is propagating normally to the direction of the propagation of the sound waves. The sound wave is traveling like this, and the medium particles vibrate normally normally. Just see 0, it starts from 0, mean, extreme, and like this it completes one vibration, and that is of 360 degree. So this is called crest. This part is called trough. So like this, even you can move forward. Again, this is crest, this is trough. Now the distance between two crest and one trough, that is known as wavelength. Again, the distance between two trough and one crest, that is also known as wavelength. You can see it. This is the figure of the transversal waves. You can see it. So transversal waves can only travel in solids, can travel in solid, and on the surface of liquid, and on the surface of the liquid. Now the next topic is sound waves differ from the electromagnetic waves. Electromagnetic waves means X-ray, gamma rays, ultraviolet light, visible light, infrared rays, microwaves, and radio waves. So here it is given distinction between light and sound waves. You can go through it. Now let us move to the next topic, that is reflection of sound waves. The next topic is reflection of sound waves. Students, we know that what is reflection? The bouncing back of the sound is known as reflection. The bouncing back of the sound waves. Once again, the bouncing back of the sound waves after striking the boundary of another medium, that is known as reflection of a sound waves. Now, the only requirement for the reflection of sound wave is that the size of the reflecting surface must be bigger than the wavelength of the sound waves. This is one of the important point which you have to keep in mind. Once again, the size of the reflecting surface means the boundary of another medium, or you can say the hurdle. The size of the reflecting surface must be bigger than the wavelength of the sound waves. Like the phenomena of reflection of sound waves is utilized in making the megaphone, sound board, and air trumpet. Now the next topic is echo. This is one of the important topic. What is echo is? Now the sound heard after reflection after the original sound has ceased is called an echo. The sound heard after reflection after the original sound had ceased is called an echo. Like the reflected sound, if heard along with the original sound, that is not called the echo. Only the sound heard after the original sound has ceased. Means the sound distinctly separate from the original sound is called the echo. That is what echo is. It is just like this. And this is the source of the sound, and this is the obstacle. You can take it obstacle, and here it is the source. What happens? It will strike. After strike, it will cease and it will reflects back. That is what echo is. Let the distance between the source and the obstacle is d. So velocity is equal to displacement upon time. So in case of echo, first it will move from source to obstacle and then again come back from obstacle to source. So the distance travel will be 2d upon t. V is equal to 2d upon t. Now students, condition for hearing an echo. The echo is heard only if the distance of the source at least it should be 17 meter, and it must reach the ear at least in 0.1 second after the original sound ceased. Point is clear, na? Like, first of all, D that must be 17 meter, and the minimum time at least that should be 0.1 seconds. These are the condition for the echo. Once again, the distance between the source and the obstacle must be 17 meter, and the echo must reach the ear at least in 0.1 second. Sometimes what happens while solving the numerical problem, the time is not given. It means that in that case the time is 0.1 seconds. Now, if there are repeated reflection at the reflecting surfaces, the sound get prolonged. This effect is known as reverberation. Once again, students, what is reverberation? Whenever there is a repeated reflection at the reflecting surface, the sounds get prolonged. This effect is known as reverberation. So don't forget, these are the two conditions for the occurring of an echo. Then another is the size of the reflector must be larger enough as compared to the wavelength of the sound waves. That is the third point. Once again, the size of the reflector means through which the light reflects, must be large enough as compared to the wavelength of the sound wave. Then the intensity of sound should be such that the reflected sound reaching the ear is sufficiently loud to be audible. So in order to solve the numerical problem of related with echo, we have to apply this relation. V is equal to 2d upon t. These are the conditions. And then use of echoes. Now echo, it has a wide application in sound ranging and echo depth sounding by using ultrasonic waves. The ultrasonic waves means the waves of frequency above 20 kilohertz, and they are more energetic than the audible sounds. So first use of it, that is use of echoes by bats, dolphins and fishermen. Now animals have different audible range of frequency. For example, bats, dolphin and dogs have a much higher upper audible limit than the human beings. Bats can produce and detect the sound of very high frequency up to about 100 kilohertz. You can note down this point. Question can be asked to you. So bats fly with speed much lower than the speed of sound. The sound produced by the flying bats get reflected back from an obstacle in front of it. By hearing the echoes, bats comes to know even in the dark the location of the obstacles, so they turn from their path and fly safely without colliding with it. This process of detecting obstacle is called sound ranging. The process of detecting obstacle is called sound ranging. Then dolphins detect their enemies and obstacle by emitting the ultrasonic waves and hearing their echo. They use ultrasonic waves for hunting their prey. Like this, you can go through it. The trawlermen or fishermen, how they use echoes, then use of echoes by sonar as sound navigation and ranging. The full form of sonar is sound navigation and ranging. Even you can go through it. Then in radar, the full form of radar is radio detection and ranging. Now both in sonar and radar, the transmitter and the receivers are placed close to each other. Now the medical use of echoes. This is one of the important, you can say, application of the echoes. In medical field, echo method of ultrasonic waves is used for imaging the human organs such as liver, gallbladder, uterus, womb, etc. This is called ultrasonography. Similarly, echocardiography is used to obtain the image of human heart. So this point you have to learn. So with this, this first part of this sound is finished. Now your homework is numericals, which are given as page number 154 and 155. Just solve this numericals, and if you have any kind of problem, any of the numerical, just let me know. I will take your doubts. So that's all for today. Thank you very much.